हाय फ्रेंड्स, स्वागत है आपका हमारे यूट्यूब चैनल जैनिता क्लासेस में। दोस्तों मैं शुभम पांडे। आज हम देखेंगे फिजिकल वर्ड पार्ट 2। दोस्तों अगर आप हमारे चैनल पर नए हो तो चैनल को सब्सक्राइब करो और बेल आइकन को भी दबाओ ताकि जब भी हम नया वीडियो अपलोड करें तो आपको नोटिफिकेशन जरूर मिले। दोस्तों वीडियो को ज़्यादा से ज़्यादा लोगों तक शेयर करो, अपने दोस्तों के साथ शेयर करो और वीडियो को यूट्यूब चैनल पर देखो ताकि हमारे वॉच टाइम भी इंक्रीज हो और ज़्यादा से लोगों तक शेयर करो ताकि हमारे सब्सक्राइबर भी इंक्रीज हो। तो दोस्तों अब हम देखते हैं फंडामेंटल फोर्सेस इन नेचर। वी ऑल हैव एन इंट्यूटिव नोटेशन ऑफ फोर्स इन आवर एक्सपीरियंस। अगर दोस्तों आपको फर्स्ट वीडियो देखना है तो आप क्या करते हैं, प्लेलिस्ट में जाके देख सकते हैं। फिजिकल वर्ड इज नीडेड टू पुश, कैरी आर थ्रो ऑब्जेक्ट, डिफॉर्म आर ब्रेक देम। वी आल्सो एक्सपीरियंस द इम्पैक्ट ऑफ फोर्स ऑन अस लाइक व्हेन अ मूविंग ऑब्जेक्ट हिट अस आर वी आर इन अ मैरी गो राउंड। Going from this intuitive notation to the proper scientific concept of force is not a trivial matter. Early thinkers like Aristotle had wrong idea about it. The correct notion of force was arrived at Isaac Newton's in his famous law of motion. He also gave an explicit form for the force for gravitational attraction between two bodies. We shall learn these matters in subsequent chapter. In the macroscopic world, besides the gravitational force, we encounter several kinds of forces: muscular forces, contact forces between bodies, friction, which is also a contact force parallel to the surface in contact, and the force exerted by the compressed or elongated spring and taut string, and ropes tensions, and the force of buoyancy and viscous forces when solids are in contact with fluids, the force due to pressure of a fluid, the force due to surface tension of a liquid, and so on. There are also force involving charge and magnetic bodies. In the microscopic domain again, we have electric and magnetic force, nuclear force involving proton and neutron, interatomic and intermolecular forces etc., and we shall get familiar with some of these forces in later parts of this course. A great insight of the 20th century physics is that these different forces occurring in different contexts actually arise from only a smaller number of fundamental forces in nature. For example, the elastic spring force arises due to the net attraction repulsion between the neighboring atoms of the spring, and when the spring is elongated, compressed, this net attraction repulsion can be traced to the unbalanced sum of electric force between the charge constituent of the atoms. In principle, this means that the law for derived force such as spring force, friction, etc. are not independent of the law of fundamental force in nature. The origin of these derived force is, however, very complex. At the present stage of our understanding, we know of 4 fundamental forces in nature, which are described in brief here. टेक्नोलॉजी की अगर हम बात करें तो आप यहाँ पे देख रहे हैं कि लिंक बिटवीन टेक्नोलॉजी एंड फिजिक्स। स्टीम इंजन कौन सी टेक्नोलॉजी पे है? लॉ ऑफ थर्मोडाइनमिक्स पे है। न्यूक्लियर रिएक्टर कंट्रोल न्यूक्लियर फिजन पर है। रेडियो एंड टेलीविजन्स जेनरेशन, प्रोपेगेशन एंड डिटेक्शन ऑफ इलेक्ट्रोमैग्नेटिक वेव्स पर है। कंप्यूटर की बात करें डिजिटल लॉजिक पे है। लेजर की बात करें तो लाइट एम्प्लीफिकेशन बाय स्टिमुलेटेड इमिशन ऑफ रेडिएशन। प्रोडक्शन ऑफ अल्ट्रा हाई मैग्नेटिक फील्ड तो सुपर कंडक्टिविटी। रॉकेट प्रोपल्यूजन न्यूटन्स लॉ ऑफ मोशन। इलेक्ट्रिक जनरेटर फैराडे लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन। हाइड्रो इलेक्ट्रिक पावर कन्वर्जन ऑफ ग्रेविटेशनल पोटेंशियल एनर्जी इनटू इलेक्ट्रिकल एनर्जी। एरोप्लेन्स बर्नौली प्रिंसिपल इन फ्लूइड डायनेमिक्स। पार्टिकल्स एक्सेलरेटर मोशन ऑफ चार्ज पार्टिकल इन इलेक्ट्रोमैग्नेटिक फील्ड। ऑप्टिकल फाइबर टोटल इंटरनल रिफ्लेक्शन ऑफ लाइट। नॉन रिफ्लेक्टिंग कोटिंग थिन फिल्म ऑप्टिकल इंटरफेरेंस। इलेक्ट्रॉन माइक्रोस्कोप वेव नेचर ऑफ इलेक्ट्रॉन। फोटो सेल्स फोटो इलेक्ट्रिक इफेक्ट। फ्यूजन टेस्ट रिएक्टर टोकामाइक मैग्नेटिक कन्फाइनमेंट ऑफ प्लाज्मा। जाइंट मीटर वेव रेडियो टेलीस्कोप GMRT डिटेक्शन ऑफ कॉस्मिक रेडियो वेव। बोस आइंस्टीन कंडेंसेट ट्रैपिंग एंड कूलिंग ऑफ एटम्स बाय लेजर बीम एंड मैग्नेटिक फील्ड। Albert Einstein, born in Ulm, Germany in 1879, is universally regarded as one of the greatest physicists of all time. His astonishing scientific career began with the publication of 3 path-breaking papers in 1905. In the first paper, he introduced the notion of light quanta, now called photon, and used it to explain the feature of photoelectric effect that the classical wave theory of radiation could not account for. In the second paper, he developed a theory of Brownian motion that was confirmed experimentally a few years later and provided a convincing evidence of the atomic picture of matter. The third paper gave birth to the special theory of relativity that made Einstein a legend in his own lifetime. In the next decade, he explored the consequence of his new theory and which induced, among other things, the mass energy equivalence in his famous equation E equal to mc square. He also created a general version of relativity, the general theory of relativity, and which is the modern theory of gravitation. Some of the Einstein's most significant later contributions are the notion of stimulated emission, introduced in an alternative derivation of Planck's black body radiation law, static model of the universe, which started modern cosmology, quantum statics of a gas of massive boson, and a critical analysis of the foundation of a quantum mechanics. And the year 2005 was declared as International Year of Physics in recognitions of the Einstein monumental contribution to physics in year 1905, describing the revolutionary scientific idea that have since influenced all of the modern physics. अब हम पढ़ेंगे ग्रेविटेशनल फोर्स. The gravitational force is the force of mutual attraction between any two objects by virtue of their masses. It is a universal force. Every object experiences this force due to every other object. In the universe, all objects on the earth, for example, experience the force of gravity due to the earth. In particular, gravity governs the motion of the moon and the artificial satellite around the earth, motion of the earth and the planet around the sun, and of course the motion of the bodies falling to the earth. It plays a key role in large scale phenomena of the universe and such as the formation and evolution of stars, galaxies and galactic cluster. Electromagnetic force. Electromagnetic force is the force between charged particles. In the simpler case, when charges are at rest, the force is given by Coulomb's law, attractive for unlike charge and repulsive for like charge. Charges in motions produce magnetic effect and magnetic field and give rise to the force on a moving charge. Electric and magnetic effect are in general inseparable, hence the name electromagnetic force. Like the gravitational force, electromagnetic force acts over a large distance and it does not need any intervening medium. It is enormously strong compared to gravity. The electric force between two protons, for example, is 10 to the power 36 times the gravitational force between them for any fixed distance. Matter, as we know, consists of elementary charge constituent like electron and proton. Since the electromagnetic force is so much stronger than the gravitational force, it dominates all phenomena at atomic and molecular scale. The other two forces, as we shall see, operate only at nuclear scale. Thus, it is mainly the electromagnetic force that governs the structure of atoms and molecules, the dynamic of chemical reactions, and the mechanical, thermal, and other properties of materials. It underlies the microscopic forces like tensions, frictions, normal force, spring force, etc. Gravity is always attractive, while electromagnetic force can be attractive or repulsive. Another way of putting it is that mass comes only in one variety. There is no negative mass, but charge comes in two varieties, positive and negative charge. This is what makes all the difference. Matter is mostly electrically neutral. Net charge is zero, and thus the electric force is largely zero, and gravitational force dominates terrestrial phenomena. Electric force manifests itself in atmosphere where the atoms are ionized, and that leads to lightning. Satyendra Nath Bose 1894 to 1974. Satyendra Nath Bose, born in Calcutta in 1894, is among the great Indian physicists who made a fundamental contribution to the advance of science. In the 20th century, an outstanding student throughout, Bose started his career in 1916 as a lecturer in physics in Calcutta University. 5 years later, he joined Dhaka University. Here in 1924, in a brilliant flash of insight, Bose gave a new derivation of Planck's law and treating radiation as a gas of photon and employing new statistical method of counting of photon states. He wrote a short paper on the subject and sent it to Einstein, who immediately recognized its great significance, translated in German, and forwarded it for publication. Einstein then applied the same method to a gas of molecules. The key new conceptual ingredient in Bose's work was that the particles were regarded as indistinguishable, a radical departure from assumptions that underlies the classical Maxwell-Boltzmann statistics, and it was soon realized that the new Bose-Einstein statistics was applicable to particles with integers spin, and a new quantum statistics, Fermi-Dirac statistics, was needed for particles with half integer spin, satisfying Pauli exclusion principle. Particles with integers spin are now known as boson in honor of Bose. An important consequence of Bose-Einstein statistics is that a gas of molecules below a certain temperature will undergo a phase transition to a state where a large fraction of atoms populate the same lowest energy state, and some 70 years were to pass before the pioneering idea of Bose, developed further by Einstein, were dramatically confirmed in the observations of a new state of matter in a dilute gas of ultra cold alkali atom, the Bose-Einstein condensate. If we reflect a little, the enormous strength of electromagnetic force compared to gravity is evident in our daily life. When we hold a book in our hand, we are balancing the gravitational force on the book due to huge mass of the earth by the normal force provided by our hand. The latter is nothing but the net electromagnetic force between the charge constituent of our hand and the book at the surface is in contact, and if electromagnetic force were not intrinsically so much stronger than gravity, the hand of the strongest man would crumble under the weight of a feather. Indeed, to be consistent in that circumstance, we ourselves would crumble under our own weight. Strong nuclear force. The strong nuclear force binds protons and neutrons in a nucleus. It is evident that without some attractive force, a nucleus will be unstable due to the electric repulsion between its proton, and this attractive force cannot be gravitational force since force of gravity is negligible compared to the electric force. A new basic force must therefore be invoked. The strong nuclear force is the strongest of all fundamental force, about 100 times of electromagnetic force in strength. It is charge independent and act equally between a proton and a proton and a neutron and a neutron and proton and a neutron. Its range is however extremely small, of about nuclear dimension 10 to the power minus 15 meter. It is responsible for stability of nuclei. The electron, it must be noted, does not experience this force. Recent development have however indicated that proton and neutron are built out of still more elementary constituent called quark. Weak nuclear force. The weak nuclear force appears only in a certain nuclear process such as the beta decay of a nucleus. In beta decay, the nucleus emits an electron and an uncharged particles called neutrino. The weak nuclear force is not as weak as the gravitational force but much weaker than the strong nuclear and electromagnetic force. The range of weak nuclear force is exceedingly small, of the order of 10 to the power minus 16 meter. Towards unification of forces, we remarked in section 1.1 that unification is a basic quest in physics. Great advance in physics often amount to unification of different theories and domain. Newton unified terrestrial and celestial domain under a common law of gravitation. The experimental discoveries of Oersted and Faraday showed that electric and magnetic phenomena are in general inseparable. Maxwell unified electromagnetic and optics with the discovery that light is an electromagnetic wave. Einstein's attempt to unify gravity and electromagnetic but could not succeed in this venture. But this did not deter physicists from jealously pursuing the goal of unification of force. Recent decades have seen much progress on this front. The electromagnetic and the weak nuclear force have now been unified and are seen as aspect of a single electroweak force. What this unification actually means cannot be explained here. Attempts have been and are being made to unify the electroweak and the strong force, and even to unify the gravitational force with the rest of the fundamental force. Many of these ideas are still speculative and inconclusive. Table 1.4 summarized some of the milestones in the progress towards unification of force in nature. इससे पहले हम देखते हैं ग्रेविटेशनल फोर्स का रिलेटिव स्ट्रेंथ 10⁻39, रेंज है इनफाइनाइट, ऑपरेटिंग एमंग ऑल ऑब्जेक्ट्स इन द यूनिवर्स. वीक न्यूक्लियर फोर्स रिलेटिव स्ट्रेंथ 10⁻13, रेंज वेरी शॉर्ट, सब न्यूक्लियर साइज 10⁻16 मीटर, ऑपरेट्स एमंग some elementary particles, particularly electron and neutrino. Electromagnetic wave 10⁻2, range infinite, operating among charged particles. Strong nuclear force, relative strength 1, range short nuclear size 10⁻15 meter, and operating among nucleons, heavier elementary particles. तो दोस्तों आज का वीडियो हम यहीं पर समाप्त करते हैं. मिलते हैं नेक्स्ट वीडियो में, जहाँ पर हम नेचर ऑफ फिजिक्स, लॉ और यूनिफिकेशन के बारे में पढ़ेंगे. तो दोस्तों अगर आप हमारे चैनल पर नए हो तो चैनल को सब्सक्राइब करो और बेल आइकन को भी दबाओ ताकि नोटिफिकेशन ज़रूर मिले, और ज़्यादा से ज़्यादा वीडियो को देखने की कोशिश करो यूट्यूब चैनल पर, और दोस्तों के साथ शेयर करो. तो मिलते हैं नेक्स्ट वीडियो में, तब तक के लिए धन्यवाद.